Okay, so today we're going to talk a little bit about prime numbers. You guys have heard of prime numbers before, haven't you? Who's heard of prime numbers? Oh, everyone. Awesome. Okay, so since you're all brilliant, I'm going to ask you a trick question. What is the smallest prime number? Okay, so let me tell you about prime numbers for a minute. Okay, a prime number is a number that has exactly two factors. Okay, they have two factors. Okay, they have one and themselves as factors. Okay, they always have two factors, one and themselves. So now with that, again, I'm going to ask you again, what's the smallest prime number? Okay, let me say it one more time. I'll say it a little bit differently. They have two different factors. Exactly two different factors. Okay. Okay, diff. Okay. So now let's try this again. What is the smallest prime number? 2. That is correct. Okay. 2 is the smallest prime number. 1 is not a prime number. First of all, it doesn't fit the definition because it doesn't have two different factors, does it? It only has one factor. 1 is itself, so it doesn't work. Okay? And then there's other reasons. We don't even want 1 to be a prime number. It would make what we use prime numbers for not work. Okay? So 1's not a prime number. So this prime number happens to be my favorite. Not only is it the smallest prime number, but it is the only what? Even. It is the only even prime number. All the other prime numbers are odd, aren't they? Okay. So what is the next prime number up? 3. Yeah, I like because I hear no. 11. Yeah. Okay. Next one. 13. No. 17. 19. 23.
27. No, false.
Oh, what?
No 27.
No 27 because 3 and 9 are factors of 27, aren't they? So it has more than two factors. Keep going up.
29.
29. 31.
This is weird.
And can we keep going forever? Yeah, there are a lot of prime numbers. There's infinitely many prime numbers. And they are very, very useful numbers. And I'm going to show you how we can use them to do some things. But I'll tell you too, people are always searching for a really, really big prime number, the next big prime number that nobody else knows about. And the reason we want to know what those numbers are is because if we know a prime number that nobody else knows, we can make a code that no one can break. So if I have to send a bunch of secret information, say I'm a government or a bank or something like that, and I want to keep my information secret, if I know a really, really big prime number and nobody else knows it, I can write a code using that prime number that cannot be broken. So if you could figure out the next biggest prime number, you could actually sell it and make a lot of money. Good luck with that. I think the largest prime number known right now has something like 200 digits or something like that. It's a big number. Okay, so we're not going to worry about that. Usually for us, these prime numbers right here, at least the ones I have on the paper. Now we can keep going. 37, 41, 43, 47, 51, 53, 57, 61, not 63. We can keep going, but we'll stick to these right here. So In order to use prime numbers, one of the things that we like to do is write a number as a product of prime numbers. Have you done that before? Who's written a number as a product of prime numbers? Okay, so we don't know how to do that. So every single number, here, someone give me a number that's less than 50.
49.
49, okay. I can write 49 as a product of prime numbers. In other words, some prime numbers that are multiplied together. In this case, it would be 7 times 7. Give me another, less than 100, give me a number.
99.
99. Give me a reasonable number here so we can do it quick. 25, okay. 25 is just 5 times 5. That's 2 prime numbers multiplied together. Okay?
32.
10. 10 is 2 times 5. That's 2 prime numbers multiplied together. 32 is an interesting one. It's actually 2 times 2 times 2 times 2 times 2.
So
Hey,
prime
shh.
numbers go into everything?
So every single number can be written as some prime numbers multiplied together. Now, if it is a prime number, like 51, no, 51 is not prime. So I think I said it earlier. 51 is not prime because it's 3 times 17. I know that 51 is divisible by 3 because what's 5 plus 1?
Oh, 6.
6, yeah. And 6 is divisible by 3, so is 51. So 51 can be written as, if it is a prime number like 17, well, you would just say, well, it's just 17 times nothing, right? Okay, but anything. Let's try 62. Stop talking. 62 can be written as 2 times 31.
Wait,
That's
is there an even number that's prime?
2.
Okay,
only
so-
2. Only 2. Okay. How about 75?
Oh, 2 can go 1 times 1.
But-
Oh, wait, never mind.
Oh my
That's 1
god.
plus 1.
Give me another number less than 100.
87.
68.
I did
I-
87.
I don't want to do 87 because 87, I'm pretty sure, no, 87 isn't prime. Because 8 and 7 adds up to 15, right? And isn't 15 divisible by 3?
Yeah.
Okay, so 3 will go into 87, so it's got to be 3 times something.
8200.
What is it? 8,200. I think it's just 29. 3 times 29 is 87. Now, I can do a bigger number, like 250. That would be 2 times 5 times 5 times 5. So every number can be written as some prime numbers multiplied together. And this can be really useful for us. I'll show you one thing that it can be useful for. If I had something like 50 over 75 and we're reducing. Now imagine these numbers are larger than they are. If I were to write them as prime products of prime numbers, 50 would be 2 times 5 times 5, and 75 would be 3 times 5 times 5. And what's 5 divided by 5? 1. And what's 5 divided by 5? And what's 2 times 1 times 1? And 3 times 1 times 1? So we can actually use this product of prime numbers thing to simplify fractions. And it's useful when the numbers are really large. Okay? We don't have to do that too much though, do we, anymore? All right? So we don't use it for that too much anymore. We use it for some other things. So the first thing you guys have got to learn is to take a number like 100 and write it as some prime numbers multiplied together. 2 times 2 times, any guesses?
2. 5.
5 times,
5.
is that 100? What's 2 times 2? Times 5? Times 5? 100. What's 5 times 5?
25.
Times 2? Times 2? Does it matter what order we do this in? What's 2 times 5?
10.
2 times 5? What's 10 times 10? Okay, so in any order, it gives us 100. So how am I doing that? Well, let me show you. Let's say I have a number like 150, and I want to write it as a product of prime numbers. Now, when you were younger, you may have learned a method called a factor tree, where you were like, well, 2 goes in there. Remember doing this factor tree thing? Okay, it's kind of like that, but this method, I like it quite a bit better. Some kids call it the upside down birthday cake method, which you'll see why here in a minute. So here's what you do. You think about, okay, what prime number will divide evenly into 150? Now, here's also why 2 is my favorite prime number. It's super easy to tell if a number is divisible by 2.
Because there's a 2.
It's even, yeah. And it's super easy to divide by 2. So if 2 works, what I do is I make a little upside down divide sign like that. And I say, well, 2 will go into 150. How many times? I heard it, 75. And I think, okay, what prime number will go into 75? 5 will and 3 will. They both will. It doesn't matter which one you use. You can use either one, okay?
Use 5.
So if you want to use 5 next, you can use 5 next. You want to use 5 next or 3 at 3? 5? Okay. So you go 75 divided by 5. Let's see, 5 goes into 7 one time with 2 leftovers. That's 25, and 5 goes into 25 5 times. Isn't that 15?
Yep.
Okay, what prime number will go into 15?
3.
I heard 3 first. How many times? 5 times. Now, see this number right here? When it's prime, you're done. Okay? So, 150 is equal to 2 multiplied by 3 multiplied by 5 multiplied by... Now, I put them in order from least to greatest. You don't necessarily have to. We're gonna, okay? So there you go. Now, if you did it in a different order, so you're like, well, 3 goes into 150 50 times. And 5 goes into 50, doesn't it? 10 times. And 2 goes into 10 5 times. Now, I still know I'm done because that number's prime. And you'll notice we still have 2, 3, 5, 5. Right? It doesn't matter what order you do it in, you're going to end up with the same prime numbers multiplied together. So this is what it looks like on your paper when you're done. Okay? Now, let's start with a little bigger one now. Okay? Sometimes I have you guys and you want to say, oh, well, 10 divides evenly into 250. And it does. But 10 is not a prime number. We can't do it. See, with the factor tree thing that you did when you were younger, you could say 10 goes in there 25 times and then break the 10 down and break the 5 down and eventually get there. Okay? That doesn't work here. The numbers you put outside have got to be prime. So what prime number goes into 250? 5. Okay. Why not 2?
I don't feel like
I think because in this case it's easier to divide by 5, isn't it? So let's use 5. What prime number goes into 50?
5.
Okay, so that's 10. What prime number goes into 10? 5. Okay. Now, am I done?
Yeah.
How do we know we're done?
You're fine.
Yeah, we're prime right there. So you come up here and you say 250 is equal to 2 times 5 times 5 times 5. Don't forget this one. We don't want to forget that one, do we? So if we multiply those prime numbers together, we will have 250. Want to try one? Too bad! Here we go. I would like you to write 300 as a product of prime numbers. It is kind of a big number.
Ricky, slide your paper up?
Yeah,
Like,
can I use
The 300? Or you want it like this?
Oh, okay, that's how you did it. Sorry.
Okay.
I'm good.
Remember, the numbers you put outside there have to be prime. You can't use composite numbers.
Is 75 a prime number?
75 is not prime. So regardless of what order you did it in, I'm gonna put 3 out here. That's just easy for me. And then maybe a 2. That's 50. Maybe a 2 again. 25, and then 5 times. So whatever order we did this in, you should have 2 times 2 times 3 times 5 times 5.
Yeah, I didn't get that.
And at the end, you should have that in that order. So if dividing is really, really difficult for you, use a calculator. Okay? You can use a calculator to do the division if you need to. And this is what I should see on your paper, just like that. Okay? There we go. So prime numbers, what about composite? A composite number means it has more than 2 factors, right? Like 4. This 4 is not prime, it has more than 2 factors. How many factors does it have? Can you name them all? 1, 2, and 4. Okay, so it has 3 different factors. Let's think about the number 1. 1's not prime. Is it composite? No, it's not. It's neither prime nor composite, is it? Okay. Maybe someday I'll talk to you about numbers that are very composite. Sometimes we call them. They're numbers that have lots and lots of factors. Like 360 is a good example. 360 has tons of factors. 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, I think 15. It has a lot of factors. We can keep going on that one. 20, 18, which is probably why the Greeks chose that as the number of degrees in a circle. It's because it's a number you can divide up into a lot of different sections like that. All right, I've tortured you enough. You can relax till the bell rings.